Hello guys, in this video I'm going to talk about the image histogram specification. So this is histogram specification that today I'm going to take. So here you can see the question given histogram A and B, modify histogram of A as given by histogram of B. Okay. So here you have two images, image A and image B. You have to modify the histogram of A. So this histogram has to be changed, and this is the histogram. This histogram should look how this histogram is. So you have to modify A, and with the help of B you have to modify A. So understanding this is one major thing in these kinds of sums. So you understand, you have to modify A with the help of B. Okay, let's see what are the steps involved in it. So it is very easy. First, you have to obtain the CDF of both the histograms. Okay, so consider I am taking CDF of A as T of R and CDF of B as G of Z. Okay, so here I have given the CDF. So here these are the gray levels, so that is 0 1 2 3 4 up till 7. Okay, and now this is T of R. So T of R was CDF of A. So here I have image A. So what I am doing, I am just calculating the CDF. So first element remains the same. Now this element is nothing but 750 plus 1023. That comes over here. Then this element is nothing but 750 plus 1023 plus 850. So that comes over here. Or you can say 1773 plus 850. Then 2623 plus 656 comes over here. Then this plus this comes over here, and the story till the last. The same thing we have done to G of Z. So this is image B. So G of Z is CDF of B. So this is image B. So what I do is 0, first element remains the same, then keep on adding. Okay, then this will add, there will be 614. You add this, you get this, you add this, you get this, you add this, you get this, you add this, and you get this. So now here you have the final histogram, CDF of both the histograms. Next thing that you have to do is match the CDF. What we do is G of Z should be greater than T of R. Let me explain you this. So now we have this table, and from this table we are going to make this table. What is this table? This is just R and Z. What is R and Z? R are the gray levels for image A. R are the gray levels. Hence you can see I have written here T of R. So T of R is just CDF of image A, where R is the gray levels of image A. So these 1 2 3 4 5 6 7 are R. Z is the gray levels for image B. So these 0 1 2 3 4 5 6 7 are for image B, and that is represented by Z. So now we want this mapping. Always in histogram we always need the mappings of the gray levels. So which gray level should be what? So that mapping is important. Okay, next. So what we do is G of Z should be greater than or equal to T of R. So you have 750 over here. You see which level over here in G of Z is greater than or equal to 750. You can see 0 is not greater or equal to, not greater, not greater, not greater. Here 1433. If you consider 1433, it is greater than or equal to 750, right? So hence what our mapping will be, 0 of R. So 0th gray level of R is mapped to the 4th gray level of Z, of G of Z. So hence for R it will be 0, and for Z it will be 1433, hence 4. So 0 4. Similarly go further, 1773. So 1433 is not greater than or equal to 1773, hence go further. 2663 is greater than or equal to 1773, hence 1 gets mapped to 5. 1 gets mapped to 5. Similarly, 2623 2663 is greater than 2623, hence 2 also gets mapped to 5. 2 also gets mapped to 5. 3279. Now 3482 is greater than 3279. Hence 3 gets mapped to 6. Now 3608. 3608. 4096 is only just greater than 3608. Hence 4 gets mapped to 7. Now if you see, all these are less than 4096, less than or equal to 4096, hence all of them become 7. So now we have got our table. This table R Z 0 1 2 3 4 5 6 7 4. So here what is the main purpose of this table? Let me clear it to you. You can see we had to modify A. We had to modify A with the help of B. Since we had to modify A, we can see all the gray levels of A. So 0, 1, 2, 3, 4, 5, 6, 7. These are the gray levels of A. Now, these gray levels of A are being mapped to the gray levels of B. So these are so Z represents the gray levels of B. So these are being mapped. So what actually this table means is that all the pixels in image A which were having value 0 should now have the value 4. So this is what this table means. For better understanding, let's take a small example. So here consider this is an image. This is image A, say a small image A. Okay. Now this is what we want the image A after modification. Okay, so we have got this table over here, right? We have 0 1 2 3 4 5 6 7 4 5 5 6 7 7 7. So what is the purpose that we want to do here? Every r that is 0 should be converted to 4. So here you can see we have two zeros, so this will be converted to 4. Okay, every 1 should be converted to 5. So here we have this 1, so this will get converted to 5. Next, every 2 also should be converted to 5. So we have here 2, so that will also get converted to 5. Every 3 should be converted to 6. So here we have 3, that will be converted to 6. Every 4 should be converted to 7. So we have 4 over here, so this will get converted to 7. We have 4 over here also, so that will also get converted to 7. Every 5 should get converted to 7. So we have 5 over here, that will be converted to 7. We have 5 over here, that will be converted to 7. So we don't have 6 or 7 in this image, so those don't come into the picture now. So if you consider this carefully, you will see there were two zeros. So suppose let me make the histogram of this, a small histogram. 0 1 2 3 4 5 6 7. So this is the histogram of this image. I have two zeros, I have 1 1, I have 1 2, I have 1 3, I have 2 4s, I have 2 5s, I have no 6 and no 7. So after modification, what happens is I have no 0, I have no 1, I have no 2, I have no 3. I have two 4s, I have two 5s, I have one 6, and I have four 7s. So this is what is the histogram of this image. So if you see carefully, what happened is when I mapped 0 to 4, that means all zeros of R. So in this image, all zeros, they turned into 4. So if suppose there were two zeros, then there became two 4s. You understand? Now here there was all ones were mapped to 5, also all twos were mapped to 5. So all ones, so there is this one and there is this 2, both of them got mapped to 5. Hence this plus this, so your answer becomes 5 for 5. You are understanding why this logic is coming. So the same way, if I consider my image, so this is my image, these are my images, sorry, and this is the table that has to be mapped. So the next table that I want to make is this table. So how will I make this table is, what you do, you make columns, make column of Z, make column of R, and number of pixels. Okay, so here we had written R is equal to 0, 1, 2, 3, 4, 5, 6, 7. Instead here you have to write Z is equal to 0, 1, 2, 3, 4, 5, 6, 7. Okay, next R. So now you do reverse. See which Z pixel is mapped to R. So here you can see there is no 0, there is no 1, there is no 2, there is no 3, there is 4, directly 4. So none of these pixels are present. So hence 0, 1, 2, 3 of these pixels will be dash. So that means there is no pixels that will be 0, 1, 2, 3. Okay, next you come with 4. So here you can see all the pixels that were 0 were now converted to 4. So if you want how many pixels of 0 were there, so you go to the table. You can see in image A there were 750 pixels that were 0. So hence now all these zeros, when they convert to 4, so you will have 750 pixels that are now 4. You're understanding? Next, here there is 1 and 2, both of them are mapped to 5. So how many pixels were 1? There were 1023 pixels that were 1, and there were 850 pixels that were 2. So 1 will also get converted to 5, 2 will also get converted to 5. So 1023 plus 850 will give you the number of pixels that were 5. Similarly 6. So here all the pixels that were 3 will get converted to 6. All the pixels that were 3 will converted to 6. So hence here you can see there were 656 pixels. So hence all the 656 pixels are now converted to 6. Similarly 7. So now any pixel that is 4, 5, 6, 7, all the pixels that are 4, 5, 6, 7 will get converted to 7. So 4, 5, 6, 7, all these pixels are converted to 7. So this is the final histogram after modification. So you can draw a graph like this. On the y-axis I have the pixel values, and on the x-axis I have the grayscale. So you can see that there is no 0, 1, 2, 3. So hence those are all zeros. Next 4, so there is 750, so this is 800, this is, oh, I have made a mistake over here. 750 should be somewhere like here. I'm so sorry. So here this is 750. So similarly 1873. So 1873 will be something above 1800. and story. So this need not be up to the scale, but it should look like it is up to the scale. So that is very important over here. Now, another thing that I want to tell you is that there are different methods for solving the same problem, and it might be that the answer also comes different. So it is okay. Actually, what all we are doing here in image processing is about pixels, is about gray levels. So you might see that by doing a different technique you get a different answer. So maybe it is possible that say over here I am getting 7 as 777, and with a different what we say, a different strategy, you get 7 as 656, or 5 as 750. So these things may change. So they may change, like here 4 is 750, so there 3 would be 750. So you might feel that the technique is wrong or something else, but the point is no technique is wrong in image processing. What happens is, when we go to the industry we deal with real images. So there the images are from 0 to 255. So our actual practical range for images is 0 to 255. So there is this wide range of image of gray levels that we have in images. So here 24 pixel value will look like, say, like this. So I guess this is 24 pixel value, and 25 pixel value will also look almost the same. So by vision, or by your senses, you won't be able to distinguish between 24 and 25. Hence these gray, if there are 7 gray levels, then you could distinguish between the 5 gray level or the 6th gray level. But when you have 0 to 2, it is very difficult to distinguish. So hence if all the 24s or 25s get interchanged, so what I want to say is, if all the fours, if there are 754s or if there are 755s, it does not really matter, because they look the same. So you will not see a very good difference between both the images. So hence both of them are right, so it is no problem. Here in these kind of sums we just want you to get a good understanding of how things happen. So basically in the industry you don't use all these kinds of sums. You basically write a MATLAB code, or you program it using a particular programming language, and you have things done. So hence this is also right. If you show the steps, you show everything, so you will get the marks. So my point is, always understand whatever you are doing, and then things will go right. Thank you so much for watching. Thank you.